you will be the JavaScript. Yeah. Okay. We still will have to wait for him because yeah. Coming. What times?
Surely someone actually in the room will JavaScribe. He's actually the co-chair.
What's that?
Trying to browbeat people on JavaScribing.
Yeah. I recruited Peter to be a note taker. Peter Thatcher said he's a note taker.
Oh, okay.
Yes.
Then one of your note takers can JavaScribe.
Oh, who did you get for JavaScribe? Oh, we did this in parallel. Excellent. So who do we have for note takers? And I think you're driving the slides. That's fine.
Yeah, or is it open slides?
Who else did you get for note taking?
I think yeah.
Okay. Mark and who else? So we have Mark, we have Peter,
Yeah.
we have a JavaScribe. Somebody must have a Java client.
I think you will be the.
Okay.
Yeah.
It'll be Paul's remote and
Yes.
Mark is note taker, Peter is note taker, and I'll watch Java myself if my Java client doesn't crash. Yeah. What? Yeah. Well, I guess we can get started, even though I can't remember. Okay, so we have tonight our ABT working group reunion tour. We will have all of the ABT groups currently meeting at this IETF in one session. So it's just like the old days. So we're going to make Colin Perkins be chair. No, wait, he's not even here yet. I can't. All right, so this one now is Avtext. All right, so we have note takers, which is Mark Petty-Duganin and Peter Thatcher. I will JavaScribe myself because nobody's volunteered unless somebody wants to volunteer just now. Magnus will do JavaScribe. Excellent. Good. Blue sheets are going around. Please sign them. Mitico, if you're remote, try to use the button because then we get to see you on the screen, which is cool, and get to use our own protocols. Note it well. You've presumably seen this before, unless if not, welcome to the IETF. And agenda today. We've tried to compress this a little bit from what was on the list because we now have all the other working groups coming up. So we might still get through it quickly. Especially, I'm not sure how much Zahed has to say about the congestion control. I think he's somewhat cut that back. Anybody have any comments on the agenda other than that? Or, okay, no, you're just plugging in your laptop. Okay. All right. Okay, working group documents. LRR is probably ready for working group last call. I have made some changes in the last draft to align the way it describes layers with the way frame marking does. So we might want to delay that until frame marking is done, just in case there's any other changes there. I don't think anybody's immediately screaming for it. So if anybody has any comments on that. Okay, RID had a publication request. Shortly after I sent in the publication request, Magnus got his comments in. So I believe Adam pushed a response to that as soon as the ID submission process reopened at the beginning of this meeting. So Magnus, if you could take a look at that and see if that made you happy.
Yeah, so Magnus Westland, I responded an hour ago, I think.
Oh, okay.
I'm mostly fine. There was basically one thing which is about the source identity called, where it looks like CNAME is the source identity rather than being a host identity, and that's I think that, and the other aspect of which I was a bit uncomfortable is the fact which, let's see, yeah, multiple SDS items of the RTP stream repair ID in being able to send in one compound. That makes me uncomfortable because I don't think any stacks really supports that. So I don't think this document should recommend that being possible. So.
All right, but do you think it's ready for Ben to start doing his AD review? Or do you want do you want Adam to do another rev?
No, I mean, I think what we're saying, I
Okay.
guess he can start doing the review, and I think this is, it's one reformulation, and then the other thing is actually removing that recommendation from my perspective, but that might need to require a little bit more discussion.
Okay. Sounds good. All right, SS header X is in the RC editor queue, so that's basically done, modulo auth 48. Splicing notification, I think still has one pending discuss. Rachel, do you want to talk about that?
Yes, currently there still has one discuss, but the discuss holder says that she did not have enough time to review it, but she promised to do it. So I guess we have to wait and to see if she's happy with the current version.
Talk to me offline.
Yeah.
And finally, CCM layered, I think, is a short draft ready for working group last calls. So, I mean, Rachel will need to shepherd that one since I'm a co-author on it. But I think that one's pretty easy, so probably we'll do that next. Yeah.
Yes. As for the CCM layer, I will start the working group last call after this meeting. So, any comments could be raised and requested for some reviews. During the working group last call. Okay.
Okay, and finally, I guess on that topic, please, be sure to review documents. There's a definite, if you want your documents reviewed, get good karma by reviewing other people's documents, and then, we can have a higher standard of all around. So, and I think that's it for the chair slides. So I guess. We have Mo, are you doing frame marking? Yeah. Okay.
Okay. Mo Zanetti. I'm going to talk about video frame marking. It's a new RTP header extension, workgroup draft, on behalf of Espen Suhas and myself. Next slide, please. So a little bit of background review, what the motivation for this work is. It's mainly for switched topologies where you have loosely calling things here RTP switch. It's not what the topology drafts would call it, but basically in topology where you're switching the media rather than transcoding it, not doing any media processing on it. And there's cases where the payloads may be encrypted. And for performance reasons, it's nice to save the decryption costs. So this could be useful. And even more importantly, there's new work such as PERC where the encryption may be end-to-end and middle boxes like switches may not have access to the key material. And so in those cases, this becomes critical. Having metadata about the streams to do effective switching becomes critical. And a more future-looking aspect is there's a potential to use this to support payload formats that you may not even know about when the switch was designed. So you can imagine supporting new codecs transparently as long as the mappings of those codecs match the semantics proposed here. Next slide, please. And then some other side benefits of this is being able to have cleaner video switching. So if you're forwarding middle box and you're switching video, you want clean video switching at iframe boundaries. And today there's not a good way to do that without inspecting the payload. So this brings it up a level so that switches have that information without inspecting payloads. And during packet loss, there's more deterministic recovery that you can make when you have well-defined start and end packet boundaries, frame boundaries. And then finally, for scalable media or media that has inherent differentiability between the packets, different importance for the packets, you can drop the ones that are least important. And so less quality of service degradation for packet loss scenarios. Next slide, please. Okay, so getting on to what really changed in this 02 version. In the last meeting, there was a discussion about adding a new field, TL0 pick index, and that's the temporal base layer, or layer 0, picture index. And that's what several codecs that support temporal scalability already have defined in their payload specs about how to identify a running index of the base layer frames. So your base temporal layer 0 will just have a running count of the frames. And it's not necessarily something that matches what's inside of the bit stream itself. So it's not necessarily an H.264 frame num or a VP8 picture ID or something. It doesn't have to match those numbers directly. It's just a running index of those frame numbers. And then in non-base layers, so in higher enhancement layers, it signals the dependency for those. There was some discussion in 92 about whether or not we should include this, and I think the consensus was, let's go ahead and add it. So if anyone feels strongly differently, please speak up now, because it's already in the draft now. And the rest of the fields were untouched, so we still have all the same semantics as before, still having the frame start and end boundaries, the frame type, whether it's an iframe or independent frame or not, whether it's discardable or not, and then the layer IDs for the temporal layers and the spatial and quality scalable layers. Next slide, please. And so to explain what the TL0 picture index was actually used for, what the motivation for adding it was, when there's frame loss, you want to be able to have deterministic recovery, know when you have a good stream coming in and you have the dependencies met for decoding that stream. And so by having TL0 pick index, after a frame loss, you can discover whether or not, when the new packets come in, whether or not you have the right dependency to start decoding that stream, or whether you've lost something that was critical that you need to now ask for further repair for. Do you need to repair the base layer, or are you okay with continuing decoding using the base layer that you've already received? Okay, next slide, please. And this is how it maps to all of the popular codecs. So again, the only addition here is that we now have the temporal layer 0 picture index for all those codecs. And again, keep in mind, this is for temporal scalability. So although these are not what you would think of as scalable codecs, for example, H.264 AVC and VP8, people typically don't think of them as scalable codecs. But here we're talking about temporal scalability, and all those codecs do actually support temporal scalability. So TL0 picture index is applicable to all the example codecs in the draft. Next slide, please. So only next step that we had open is whether or not, if your codec does not support any form of scalability, your usage of the codec. The codec may support it, but if this usage of the codec, your encoder itself, is not taking advantage of scalability, is there any point in signaling these parts of the frame marking extension that only apply to scalability? So one possibility is that we could, eliminate the temporal layer ID, TID, the layer ID, which is the spatial and quality layer ID, and TL0 picture index, because all those values would be zeros for any non-scalable encoder. So an option is to have just a 1 byte extension if we want, and eliminate those others. And no new encoding or anything is required for that. Just the length would be enough to signal the difference between whether scalability information is included or not. So that's one option that we could explore.
Speaking of individual, I just don't feel like standing up. There actually are use cases where just having those 5 bits would actually be useful to people.
Which 5 bits?
Those, the SEI, D, and B, which is all the information you still have.
Yes. Those for packet loss scenarios, those other bits are still critical to be able to deterministically recover and to do things like switching at iframe boundaries. So those bits are still useful no matter whether you have scalability or not.
burnout about Microsoft. Yeah, I mean, there's simulcast scenarios where you could use this where there's no scalability. And the only comment I had is the way you're describing S&E, you say it's the first and last frame within a layer.
Yes.
But in this case, it wouldn't be within a layer, but it still makes sense.
Yeah,
Right.
layer, if you have layer. If you don't have layer, frame.
One layer, I guess.
Yeah. I'll take that. In the notes, please remind us to double check that we do spell out clearly that those are for start and end of a layer if it's a layered codec. I'm pretty sure that's how it's already worded in the draft. Okay, it's worded like that in the draft already. Yeah. Okay. So do folks think it's worth having this optimization, or nobody's worried about the extra 2 bytes? I don't think it's much complexity. It's just, interpreting the length is.
Yeah, I mean, Jonathan, I mean, I think that I would say that yes, because I mean, teal 0 pick index does have semantic meaning, even if you're not. I mean, it's a frame counter otherwise. So basically, this means that it's. I would say yes. This should, lengthening it means that you're removing the teal 0 pick index as opposed to.
Yeah.
I would say that if you didn't shorten it, then technically you would have to have teal 0 pick index as a frame counter under the definition of it.
Right. Okay. Yeah. So zeros and not present are really two different things.
Yeah.
So we should have not present explicitly.
Yes.
Okay.
Again, as an individual.
Okay. So
What is it that starts and ends? S&E or the start and end?
the start and end bits should mark the start and end of a layer within a frame if it's scalable. If it's a layered codec. If it's not, then it's the start and end of the whole frame. I believe it's already worded like that, but we'll double check.
Hi, Colin Perkins. This is a header extension. Right?
Yes, RTB header extension. Well,
does
yes.
shortening it actually help because of the padding?
Well, potentially we're going to have a lot of header extensions coming our way, right? I've seen plenty proposed. So, yeah. So the goal is just to make it if it's only a single header extension, then the full 32 bits is fine. But we expect it to be stacked with more. And there was even a proposal when this was first brought up is, should we even have one header extension or should we break it up into 2? Should the scalability information really be another header extension and put the TID and lid somewhere else? But we decided to go this way. All right, so if no objections, I'll go ahead and make an update to put the byte reduced format in the current draft. And one of the clarification we added in the draft, which I didn't put in the notes, was that all the examples are showing the 1 byte version of the header extension, but I believe there's some new work in 5285 BIS that's trying to deprecate that 1 byte version. I'm sorry.
You go to the mic, please.
Ronnie Evan, it's not deprecating. It's just saying that if you don't know since how many you have, you should use the 2 bytes because some intermediary may add their extension in the middle. So and you don't allow in the same packet to have two
Right.
types. That's all.
Okay. Yeah, we put some rough text around that. Just all the examples in the current draft are all 1 byte, but then we say, of course, it's usable with 2 bytes, and if you're trying to mix 1 and 2, it's not possible in the same packet, so you should use 2 in those cases. But good. So if we're not deprecating it, then I think the draft is fine as it is. We'll leave all the 1 byte examples for simplicity. So that's it. I think other than that, this draft is probably ready to go. We'll make that one change and be done.
So does anybody else have any other open issues with this draft? Or actually, I mean, as an individual, I may, which is that we may want to define, we should figure out where to define usage of, so the LRR draft has payload specific descriptions of how you recognize a layer refresh point. I'm wondering if we want to have something that just says, I don't know whether it's in this draft or LRR, how you recognize a layer refresh from this header extension.
Well, along the same lines, I think back before this was adopted, the individual version of this, there was comments about should we have guidance about all of these bits, all these fields, and basically, have like an SFU implementer's guide, an endpoint receiving data from an SFU implementer's guide about how to use all this information. And we backed off and pointed to Bernard's draft, which was sort of doing that. But I don't know what the status of that is and if we plan to progress it or not. I agree that the information should be somewhere, but I'm not sure if if it should be in this draft.
I mean, arguably it should be an LRR, which means that then it's not ready.
Because the concerns are really larger than just these fields. I mean, there's other RTP header fields that,
Right.
that are in scope, and it probably needs a larger discussion than just this header extension.
Just a Bernardo, but just a question for Jonathan. I was actually thinking about that. And could you just for a second think of what bits would be set at, for the LOR refresh point?
I mean, I suspect the answer is it's, this is similar enough to what, I mean, certainly for a temporal only, it's straightforward. For the spatial, I need to.
Right, for the spatial. Case.
Yeah, I mean, and if it turns out we can't, then maybe we need to look at this and say.
I was looking at it, it wasn't obvious to me what would be set.
Yeah.
Because it's not,
Which might mean we need to revisit this.
wasn't obviously covered by everything in there.
Yeah.
I wasn't, yeah. So that's something to look at.
Yeah, so maybe we should meet offline to discuss, whether we, if we can't figure out a layer refresh from this header, that's a bad sign.
Yeah. Yeah, we should make sure that interpretation of all of these bits and other drafts like LLR
Yeah.
is clear, and then where to document that
Yeah.
clarity.
Right. Okay. So let's figure out some time to meet offline about that.
Anything else? That's it.
Thank you.
I guess
Okay.
so for the layer refresh point, the I bit would not be set, right?
No, it would not.
Yeah, so that's the problem because
Yeah.
there's no.
Yeah. Right. So I mean, that's what I'm saying. Like the VP9 payload spec I wrote is much larger than this, and much of that is for a good reason. So, all right. Okay. So I think we're doing pretty well on time. Was that? No, he pre-upload. There's a on the tracker app. There's like a three slide, a shortened presentation. I uploaded that like an hour ago. So, say for if anybody who's following along at home, or if you want to get the slides up on your laptop, there's the slide for is ahead here. Oh, there you are. Okay, yeah, come on up while we're finding your slides. There, that's fine. Good enough.
Hi, my name is Jahed, and I'm gonna get an update.
What? Well, no, I mean, he can present to this version if he needs to. Oh, I see. You need to. Oh, you need to download? Okay. Okay. There we are.
Okay, so my name is Jahed Jamal Sarkar, and I'm going to update you guys about something we're trying to do in RMCAT that has some relation to, or a lot of relation to this working group. So we'd like to inform you what's happening there. So next slide, please. So we formed after last IETF meeting, we formed a design team, and the goal of this design team was to, in RMCAT working group, we have the 3 proposals, and we'd like to make them interoperable. And one of the way of doing is like you have a generic feedback format, and then the design team supposed to analyze the requirements. If there is similarity, if there is possibility, we should make a generic feedback message. So that was the goal. And of course, one thing need to be noted that we are only considering sender-based congestion control. So the receiver collects all the metrics, all the information, send it back to the sender. Sender analyze, determines the capacity or available bandwidth, and react to that one. So next slide. So so far, what we have done, we have identified three different information that is reported, that is needed per packet. As like packet identifier, we have RTP sequence number at RTP SSRC, so that could work. And then we have packet arrival time, and then of course we need to be more futuristic, and we would like to include ECN marking So we need some way of convincing this information back to the sender. Yes. So and the idea here is like we'll have this information block, packet level information, will be grouped by SSRC, of course, and then we'd like to. The current idea is to have an XR block carrying this information, and if when it's regularly reported, and when you have more frequent one, you might want to have an ABPF feedback message. So this is currently on a work in progress. We in ARMCAT we decided to prolong this design team. So the idea has to again come to you and say like if you have some early input on the packet wire format of this information, that would be really helpful. So next slide. So there is we have produced a draft. It's out there. You can read about it. You can read about the different rationales we're talking about. These are the rationales we're talking about. And it's also available on GitHub. If you want to raise some issues or contribute, send pull requests, we'll be very happy. And we're also bi-weekly, we plan to have some meetings. So if you're interested, I'm gonna send an invitation to Avtext mailing list. And the message is simple: join the design team.
Can you say anything more about the design issues you're working with on there?
Design issues. If you go to
Mozinati, that there's another draft in RMCAT, Colin's draft that talks about it's draft IETF, RMCAT, RTP-CC feedback or something like that.
Feedback frequency and over, yes.
So it talks about, it gives examples of the feedback message sizes and frequencies and all that. And it was a very enlightening presentation by Colin a couple hours ago about the infeasibility of this current design for most bandwidths that we're talking about. I think that it's like 2.5 meg and above, we're okay to give feedback at every frame, but below that, we're potentially in trouble. So if you want to be on the design team and help figure out a good way to get this data down to something usable by most bandwidths, sign up.
Yeah.
I think that's slightly overstating what my previous draft says. So I think that the issues with this draft are figuring out what information needs to be fed back and how best to represent it, and things like what timestamp accuracy you need. We need what's the range of time which you need to report on, and so on. And once we've done that, it's figuring out how best to represent that in the packets. The other draft in RMCAT has done some very, very simplistic analysis to show how our TCP would work with one particular set of things. Now, obviously, if you lower the frame rate or you lower the bit rates, then the things change, and we haven't yet done the analysis for that. And yes, the simplistic analysis says it works at 2.5 megabits, but that doesn't necessarily mean it doesn't work at less than 2.5 megahertz. We haven't done all of the analysis. And there are obvious ways of optimizing the rest of the packets, not just this feedback. So the analysis is very much ongoing. But it's basically figuring out how to trade off the accuracy of the feedback you're getting versus the overhead of that feedback.
Yeah, that's basically the issue. I mean, I would agree with that. I mean, the thing we have been discussing is like, well, everybody wants per packet feedback, but that's not perhaps possible. And even we have talked about some ideas like let's define condition feedback bandwidth perhaps separately. But I think these are the things that we're dealing with, and obviously you're the experts here, so design team.
Mo, again, I think one other aspect that's really important for people here is try to help define the interaction between all current AVT feedback and RTCP and header extensions and things like that with this new basically ACK-based feedback. So, how does Timber and NAC and all the other things, how should they, and FIR, LRR, how should these all relate to this new feedback message?
Yeah. Yes, and also, but we need to remember, like this is only related to condition control. We're not trying to say like, okay, we'll find out and super bullet that actually solves all the other things that you're talking about. We're particularly focusing on CC feedback.
Right, but let me give you a practical example. I think in the ARMCAT session, it was mentioned, I asked specifically, would this mean you stop sending, as a receiver, would I stop sending NACs? And the immediate answer from people in the room was no, you still have to NAC. But if you look at it from a video perspective, the sender knows what it sent, and it knows if the frame was important or not. The receiver knows it lost something, but it doesn't know the frame marking of what it lost. So the frame marking header extension is useless in that sense. But if the sender would know, and we have full ACK maps of everything, then that could be implied as loss, and the sender would decide whether or not the loss was important enough to need to be recovered or not. So in that case, my answer as a video sender would be, yeah, stop sending me your NACs, receiver. I can do a better job of sending you your repairs than you can asking me for repair.
Sure, I agree with that. But my point was like, well, if you can be so smart that you infer some, I mean, nobody is restricting you to get this information from this kind of feedback and do something smart. And if you actually say like, okay, I'm getting this, I negotiated this new messages, and basically you don't need to send me NAC, fine.
But I think it'd be good to have something that just talks about some of those, maybe just informative, doesn't maybe have to be normative language, just something informative about, if you have this feedback, then maybe you can obviate the need for NAC if your receivers, understand that they'll still get repair from a sender that understands this.
That I agree, yes.
Colin Perkins, I think it changes the way you use our TCP if you have a continual feedback channel for all of the lost and received packets. And the way you use things like the NAC extensions, the picture loss indications, the fast inter requests, and so on, is probably quite different if you're getting feedback on every packet that was received than if you're just getting it occasionally. And the mechanisms people are used to doing with those have a certain cost to them, which may not make sense if you also have this. And we need to figure out what's the right trade-off between the different types of feedback. And I think there are some pretty subtle issues which we need to work through there.
Yep.
Varun Singh. So just going back to what Mo said, so the bigger problem is when the receiver does not send a NAC and sends this ACK stream back, doesn't know if the sender will actually do the right thing or not. And that's really difficult for the receiver to know right now, because it sends this thing and doesn't know if the sender is going to do the right thing or not, because it never told anyone that it would send a NAC if like it would interpret the missing packets as a NAC. So you need some additional information there.
Stefan Holmer.
Hold on, we ran a little before you went. Yeah.
Hey, I agree with what was just said, and also there's another complication in that just because the packet was lost, that doesn't necessarily tell you what the receiver needs in order to recover. Have they gone past their jitter buffer and just decided they've thrown it away and they just want an iframe for repair, or are they holding holding things, waiting for the packet to come in, waiting for a retransmit? It gets complex and not obvious without additional information. So I'm sending an email with a bunch of stuff about some of the things that Colin mentioned and the results of Colin's analysis, and I'm resending it with a bit more information to both Avtext and ARMCAT.
Thanks, Randall.
Stefan Holmer. I think if we're going to use something like this for loss recovery as well, we will have to add some kind of extensions, because if, for instance, the feedback message can be lost, and then you don't even know if the packet was received or not, and
so
probably you don't
that's what I'm my interpretation. As I see it, I mean, all this signaling of doing different things could actually help each other, but do I need to really design something for congestion control that also takes care of other things? I'm not sure. I'm not at least convinced right now, but
I don't think we should solve all the things in one graph.
This just makes things complicated. But anyway, I mean, we should discuss this one. I agree with Mo that there should be some sort of informative information, like in the drafts or whatever we produce.
Varun again. I think one of the things that comes out of this discussion is perhaps the first point or the second point of your last bullet is the fact that do you want to send this with a full SR and RR or not? And I think that might be like a larger decision to make if we think that we're blowing out the RDCP bandwidth budget.
Yeah.
And I think that's where like feedback from implementers who've got implementations out there know what kind of additional information they would be sending in addition to the SRs and RRs, like kind of knowing what's there. We would then be able to like figure out how much this feedback message would get in terms of bandwidth for the RDCP.
But as you see, like there are lots of issues. I mean, Colin asks what are the issues. There are lots of issues. Please help us in the design team. And obviously, this time, I mean, we have been only doing it in ARMCAT, but we also believe like we should involve Avtext in the design team. So we'll announce it meetings. Thank you.
The other point which was raised in RMCAT, which I think Colin was asking for, is sort of to figure out what are the use points that people are hoping to use this at. So sort of like what bandwidth and what bandwidth of feedback and what responsiveness of feedback are you hoping this will work at? I mean, and obviously, you can get incredibly over optimistic, but what is sort of your realistic expectation of what the overhead of this should be?
Yeah, I mean, there are obviously certain sort of combinations of sort of bit rates, frame rate, audio, video, screen sharing, various other header extensions, and so on, which people want this to work at. And there are some where it's clearly unreasonable, and it would be useful if people could sort of send some suggestions for sort of typical operating points where they expect this to be useful, and send them to the list or send them to me, and then I will make sure the next version of the draft includes all of the points which are of interest to people. Well, unless people send me like 500 of them.
All right, I think that's it. All right, any other business for Avtext, or should we turn over to AVT Core? All right, I have no idea what's going to happen with Metaco right now, so possibly we should ask them. I will let Metaco know. So hopefully they'll do they'll figure out. They said okay, so figure out what that means. Presumably that means you should join the AVT Core room.
Running for your laptop?
Yeah.
Running out of power.
What about the blue sheets? Do they have separate ones? Or?
Yeah, I assume so. I'll go fix those.
How's that relay for you guys?
You have your Jonathan. Did you take your blue sheets?
Oh, I'm going to get looking for me. Yes. Different groups of press coaches. I mean, it's time for next. I mean, we don't have that anymore. Actually, I tell you what, we'll just stick the AVTX sheets underneath, so it came in like signed for both. Halo doesn't have its own sheets. This one has AVTX sheets.
Start them from front.
So,
ABTX underneath. So. Yeah, start.
So if you didn't sign ABTX, sign it when it comes back.
Yeah.
Unless you just came in the room.
we have note takers?
Yeah.
Just verify.
Yes. Where I have my note taker? I think it's fine. So.
We have note taker?
Yes, I sent you a mail about that.
Who's taking that?
Mark.
Mark? Mark?
Yeah.
And who else? Or someone else?
No, I think we're fine. I can take those.
Okay. Okay. Sure.
Okay, so let's get going. So, welcome to ABT Core. Next slide. Yeah, I'm Magnus Westlund. This is Ron Eben. The note well still applies. So, so this is the share status update. We're going to have actually a separate presentation on the multipath RTP, which isn't on the agenda. And we have then two main topics for this working group session is the header extension, general mechanism for header extensions update, and the circuit breakers for RTP. So we had no RFC published, but we still have 3 in the queue, and let's hopefully get them out of the queues at some point, but that requires, I think, MUsic to do its work. Yeah. So. Yeah.
Hi, Colin Perkins. The multi-stream optimization.
Yes, you're right. It actually made it out. What?
We may need to do an update to that.
Yeah.
Because I mean, one of the things that came up in that RMCAT draft is that the identifiers are pretty big, and I don't think they need to be.
Okay.
I think it's a pretty simple update, but we may need to rev it.
So is it? So is it an editorial change, or is it something that we need to take it back from the?
So what it currently says is that the identifier for the reporting group is formatted like a CNAME and has all of the uniqueness properties of RFC 17 Mumble, whatever it was, the new CNAME extension thing. In practice, I think that's way too much, because you end up with these enormous identifiers, and you can just get away with a couple of bytes for the reasons we're doing it. So I think we should possibly revise that text to say, you pick an identifier, make sure it's unpredictable and unique and all of that, but it doesn't necessarily have to be long.
So that means we need to take it
back. So it's a technical change, but a pretty simple one.
Yeah, but that means we have to take it back to the working group to approve.
Yeah, sure. But given that it's blocked, waiting all this stuff anyway, it's not going to delay it.
So just so at least we should remove it from the RFC editor if we don't want it to suddenly.
Sorry, people do. So can we get some proposals for what the actual changes on the mailing list and try to agree if that's needed or not before we pull it? So.
I don't think this would delay anything because it's blocked waiting a reference anyway.
Yeah, sure. But I mean, still, I think we should agree on what change we want to do before we actually pull it from the queue. So yes, ISG processing, circuit breaks can be discussed later, and I guess you want to talk to Arya.
Yeah, the ARIA SRTP, there's informational draft registers for DTLS and MyKey. Just updated the write-up before the meeting, and the area director should look and see how to progress that. The other one is the SDS, which is a standard track for SDS registration, and it is ready for Working Plus call. So we'll probably do one and try to finalize this one too.
Do you want to synchronize those
No, they don't have any relation. They're just registering.
Okay.
It doesn't matter. They're just registering the suite inside the correspondent YANA registries. That's all. They're doing all those. So they don't need to be coordinated.
Okay, and that was Ben, by the way.
Okay.
So, and the RFC 5764 max fixes update. It's in IETF last call. There's some discussion ongoing on the main list about the AD comments, but I think it's gonna have progress on that, so no problems there. We have no other documents. The other documents is not presented. Well, multipath is gonna be presented, and the 5761 update, which clarifies the SDP offer answer, negotiation of RTP and RTCP multiplexing. So the text reflects the consensus on the list that was discussed before, and we plan to do working last call very soon, because it's just one thing it really changes. So, and that's already been discussed. So. Okay, I guess it's next. Do we have it? Yes, and then I get to carry the hat of shame or something. So guidelines for using multiplexing features of RTP to support multiple media streams. This draft is expired since a while. The issue is that we actually have to do major restructure and rewrite of it. I took that on me, and I haven't done it. And that was planned in Yokohama to do this, and so it's 2 meeting cycles without producing a document. I'm sorry, but yeah, I'm really gonna try to get it done before Seoul. So yeah, our current milestones, we got some updates for certain thing finished, and we actually only have 4 milestones for the moment. So, and I think the
And one we moved to other work.
we moved the AQT to Perk. So yeah.
Interesting way to finish milestones, to move to another one.
Yeah. So yeah, I guess we finished, and it's Varun. Then yeah. Let's finish that. It should be short.
I'm Varun Singh, speaking on behalf of my co-authors and Balashpreet, who helped me put together the slide deck, especially the results that come towards the end. Next slide. So we made some updates over the last 2 versions. They were mainly taxonomy was updated. I found a lot of things that don't match with the RTP taxonomy, so I created some new, and this probably needs a lot more review. I'm looking, hopefully, from the people who wrote the taxonomy draft to actually go review it and say if this makes sense or not. I try to take those changes halfway through the document, at least the introductions, and before the packet formats come up, so at least people can read it and say if it makes sense or not. Most of the changes were because this draft was written before the taxonomy came up, so circa 2011. So there were a lot of inconsistencies before. So review there is much appreciated.
This email was not on the mailing list. It was a private email from Frederick Mays, right? So we didn't see it on the mailing list.
Yeah, you've not seen you've not seen the email from Frederick on the mailing list. Do you want him to send it to the mailing list?
No, that doesn't matter. But
okay.
So people will not search for that. I mean, that's all.
All right. So the major change was the fact that the sent RTPC stream says something like is identified using the 5 tuple, and the whole RTP stream is like somehow associated to the 5 tuple. And this is not the case with multipath RTP, where you want to send a single RTP stream over to 2 or more, or 1 or more 5 tuples. So this is I created some new taxonomy related to multipath for this. Next slide. So the implementation status of MPRTP right now is that it's been implemented as a GStreamer plugin. It's available at GST MPRTP. It's been we've working on integrating this into OpenWebRTC so that we can perhaps do a demo later this year or at an upcoming IETF where we would be able to show GStream this thing work with the WebRTC, for example. There's a talk from last year from Balazs at the GStreamer conference about upstreaming MPRDP into their code base. Next slide. Some of the work that we've been doing with MPRDP and applying it to congestion control here, there are two paths where the second path is fixed, the first path oscillates. What you can see is that the congestion control is able to move the packets from one path to another, or also reduce the rate in this case. Next slide. Here you have a stream which is at 1 megabit and like one path with 1 megabit constant and the other with 2 megabits. You can see that they both ramp up and you get about, on both paths, you're able to do 3 megabits per second. This is a more convoluted case where both paths are changing capacity at different time scales. And what we see is the congestion control with multipath is able to do both scheduling on both paths and use optimum capacity in both cases. So one of the things that the draft's been there for a while and it really requires a lot more review. I'm hoping that some people would take their time and do that. There are two open issues though. One is the fact that there's the draft has an interface advertisement in RDCP, which is something that we could do less with. We could do this in ICE, we could do it somewhere else. It'll stay in the draft until we come up with a strategy on a way to do this. So I'm hoping that people who are looking for inspiration on new problems can look at the draft and actually think about possible solutions. The second thing is security considerations is definitely lacking. We've implemented this with OpenWebRTC, so we've done some stuff with DTLS here. The simple thing that we did was we reused the DTLS keys. I'm not sure if that's the right thing to do or not, but this is something that is also something that we would require more guidance on. And people who are interested in this should sync up with me so that we can see how we can use DTLS over multiple paths.
Emil Weevoff, on the multi-path thing, I'm thinking that maybe we should review the goal to have this published as an RFC in November, because I think it would be a bad idea to publish it with interface advertisement over RTCP. And I don't see realistically a nice way, given that it's not, I mean, there's no work on that happening right now. I find it unlikely that it would suddenly miraculously emerge by November. So yeah, just a thought, maybe we'd like to push that back a little bit for the chairs.
Yes, well, I mean, there's a possibility. I mean, the question is, what if you're saying that you basically make a statement now that we will not be able to finish the work because there's not sufficient energy to complete it in the current milestones time frame? Or is it that the technical problem is not tractable at all?
It is that the technical problem that this depends on, and it's supposed to be addressed in a different working group isn't being looked at right now.
Okay.
So perhaps the way forward is to actually say that if the interfaces become available or are, so that's one way of looking at it, is saying that the interfaces become available, MPRDP can use it. The other is we'd say that we do it in RTCP until there is a point where people would know how to do it. Because this is what exactly MPTCP does. It does the interface advertisements within in-band within its own payload. And if people find a better way of doing it, we would just come back and rep the spec and say,
So the reason I'm worried about this is I think the approach that's currently in the draft, and it's been a while since I read it, is a little bit naive in terms of interfaces. It's not only about interfaces, it's about candidate pairs. It might be the same interface locally, it might be a different remotely. And
And all of these issues have to be considered, and it would be a shame not to have these considerations in the multipath draft, is what I'm saying. Now, obviously, if we're set to absolutely publish and respect the deadline, and that's more important, then fine. No.
But I think the draft just says that these are the candidates. There might be some extra bits that we can assign to saying that these are the stun candidates, and these are turn candidates, and these are local host candidates, the same way that we do in ICE. So I think that we could definitely do that.
Bernard about Microsoft, just a comment, kind of echoing what Emil said. You know, we're doing all these things in ICE to allow passive-aggressive nominations, so you can be switching interfaces, switching paths. And then, you know, if this is also trying to do stuff like that or assumes it's not happening underneath, you kind of need to think carefully about what happens when those paths do shift, right? Do you reset, you know, all the congestion counters, and because this stuff is going to happen underneath you, right?
So one of the things that we show both in these results and the results before this comes in the paper, and we've shown that the congestion control's responsibility is to figure out shared bottlenecks and see if the paths are being used by are distinct or not. And in those cases, the congestion control will do the right thing, that it would probably not use those paths. But that's a totally different question, because that's not something that the draft talks about. The draft says that here are paths that it could use. There may be pairs that might be like the same paths eventually. And maybe that's the congestion control that needs to then make the decision on using them or not.
So, Colin Jenks, I think it's well worth publishing this work even before we figured out how to use it with ICE. Perhaps it needs a warning that says, if you try and use this with ICE, it's really complicated and that work's not done yet. I have no problem with that. But I think this does stand alone by itself and is not worth holding up, waiting till we understand how we make this interact in an ICE type situation.
Thank you.
Peter Thatcher, to go along with the ICE discussion. Yeah, multi-path ICE is not really a thing, at least not yet. So you wouldn't be able to rely on that, and you'd have to have something that said that that's not there yet. That's not a thing. As far as the security considerations, I don't see why you wouldn't just use the exact same security context for different paths. You know.
But we did the experiment works. I'm just wondering if that's the way you want to go. Like, I'm not the security expert, so maybe someone needs to perhaps look at the possibility of threat in some way.
So I think it's fine. In our limited extensions to ICE that we've made that are not standardized, that are somewhat multi-path, you know, we just use the same security context. We don't change it.
That's heartening to know. So we'll just go forward with that.
Personal comment here, yeah. I mean, as long as you're not creating 2 times path, so as long as you're actually getting different IVs for each packet, that's just the important thing, because the different path packets going to be different, and then you end up with 2 time paths. So that's really what you need to check.
Right.
Sorry.
Yeah.
You just need to put what Magnus just said. That's it. That is your security concerns action, and you're done. So Magnus will send text. Action item for whoever's taking minutes.
Cool. That resolves both issues.
Experimental.
Yeah, the experimental, I have no problem saying. I don't know how it works.
So, yeah. It's you. Yeah. Yeah.
This is the okay. This is an update to the RC 5285. Go to the next slide. So the changes from the last IETF meeting was to address comments from Colin, which were mostly editorial. That's in the current version includes these changes. And next slide, which is the open issue. There was a proposal to add text providing general consideration for getting the header extension delivered to the receiver. which was not in that document, and it came as a comment to other document, but it made sense to put it here because this is the general document, and as long as we are updating it, it's a good idea to do it in this document. Dave Zinger suggested using the text from section 4.2.3 of the SDS header extension, and to split section 4.1 of the document to subsections because it became very big, this section already. And I sent a proposed text to the list for comments, but didn't get any feedback yet. I'm still waiting for feedback. Have another slide, so just yeah. So I hope to be able to have a new revision that will include the proposed text on transmission consideration, and then the version will be ready for working group last call.
Jonathan Lennox. I think, I mean, I don't actually remember, I'm sure I saw that text. I don't actually remember what it said, but I just want to make sure we're clear between the difference between things like SDS header extensions, which change occasionally, and so you only need to send them when they've changed, and things like, say, frame marking or simply time code, which will be different for every frame, unless you need to send them all the time.
I think the major point that was already discussed there in the current document was that we currently, before the header extension, you are not supposed to send something that is important, basically.
Yeah,
and now we changed it. So the moment we changed, we said, okay, now that's why we need the consideration. Now that depends. Of course, the text says that it depends on the header extension itself. I cannot give a recommendation for each header extension, but it depends again on the header extension itself.
Yeah, I mean, I think we can give guidance of
guidance.
Things like, there's several categories: things that are expected to never change, things that are expected to change only occasionally, and things that are expected to change all the time. I think those are
the question was not about. The question was more about how many times you have to send it in order to have a reliable, that will provide some reliability that it will get to the other side. Not about how often it changes.
Well, I mean, I guess my point is that my point is something that changes all the time, the reliability consideration isn't relevant, right? Because it needs to be.
Yeah, of course. I mean, if I have to send it 5 times and every packet is changed, then it doesn't matter. You get whatever. I mean, but probably you need to see.
Yeah, I think Jonathan has a point here that you might need to clarify that there is these different classes of changing behaviors that might need to be conveyed on of whatever the header does, and therefore you do or do not care about actually detecting the change or not. So.
Okay. So I assume it will be relevant to the last one. I mean, the last one will have to be in these changes if you have often changed, but you don't know which is the last one, right? Okay. Okay, I think that's my presentation.
Colin?
So just comment. So just review and say comment on the current text. Yeah, so I'll be able to finish that.
So we have a pink box positioned where you can actually see the slides you're presenting, which is a rarity. So hi, I'm Colin Perkins. This is the RTP circuit breaker draft, which we've been doing with Varun. This is a draft which we started this 4 years ago on the basis this would be a piece of cake. And we're still going. Right, next slide, please. That's the goal, yes. we also thought WebRTC would be easier than it was. So, so we finally got this to IETF last call in February this year. We then got, in March, we got a bunch of comments from Ben and from the Ops Directorate. In April, we got a bunch of comments from Spencer, and in June, we got a bunch of comments from Stephen and Alyssa and Maria, most of which had Discuss on them. Next slide, please. Right. Most of these, I think, were actually pretty good, pretty valuable things, and that they were pretty simple, non-controversial changes. The comments in -14 from Ben and the Opster, they were, I mean, they were clarifying that you shouldn't disable the circuit breaker if you have no other way of getting indication that there is congestion. If you're not using RTCP and you have some other way of detecting there's a problem, that's fine. You disable the circuit breaker. But if you don't, then you probably want to be stopping at this point. It clarified what it meant by the fraction lost field. It clarified what we meant by persistent congestion, as in congestion for tens of seconds. It suggested that if you're monitoring RTCP reports and you see that there's some indication that you're getting 40% packet loss, maybe you should be flashing up a little blinker light in your user interface to tell the user that. It expanded the discussion about what you do if you're using different diffserv values in a bundle group, and it fixed a bunch of references and glitches and that sort of thing. And none of that seemed controversial at the time. Next slide, please. The next one was an update to address some comments from Spencer. We had a comment in the draft that if a flow gets halted by the circuit breaker, it should not be restarted automatically unless the sender's got some information that the congestion is dissipated or can reasonably be expected to have dissipated. And he wanted an example of what that information might be. So we put in an example of, well, if you're a mobile device and you know you've moved to a different network location, then probably your network conditions have changed, so it might make sense to restart the flow automatically.
Bernardo Mober, Microsoft. So Barun, with respect to WebRTC 1.0, posted an issue which actually relates to some of this, which is like, what is the expected WebRTC 1.0 API associated with a lot of these things? And that brought up a discussion of exactly some of these points, because is the expectation that one of the questions is it a RTP flow will stop? And is that something that needs to be evented so you know, hey, it stopped this thing? Or is it something the browser might just recover and therefore you don't need the event because it'll just come back? Does things like ICE, changes, then reset the thing? So what does the app developer do? Do they, can they address this by doing an ICE restart and therefore know that it will then restart at that point? So we kind of got into a situation where we actually really didn't know how to support this within the WebRTC 1.0 API because the behavior in the draft wasn't sufficiently clear for us to understand how to do that.
Sure. So what are you suggesting for this draft?
Well, I think you have to decide as a model whether this is something that the app is going to have to incorporate or it's something the browser is just going to fix, right? In which case the app doesn't really have to care.
I think that's something for the WebRTC to decide. It's not
So
necessarily
the existing
specific.
specs say this is something the browser must enforce, not the JavaScript, right? And all the questions about eventing and notification stuff, I totally agree, but I think that's totally a WebRTC issue, isn't it?
Well, like as an example of the question is like the question is, should there be an event? And then the next question is, great, the app, we now told you. You do.
But I don't think that affects this draft.
Do you know what your options are? Like, I can make this thing go away by doing a nice restart. I can, you know what I'm saying? Like, I gave you the event. Well, great. Colin.
But does that have anything to do with this spec?
Well, it does in some respect. If you're leaving everything up to the implementation, then you're not really saying like it stopped and I need to, it's not clear. And that's the guidance there. Is it? It says it should not be restarted. Okay. So I get this event and then I say, well, maybe I need to kick it.
Well, it says should not unless. It says should
unless,
not be
but that's the
restarted
problem.
unless.
It's like, unless is it something that I do as the app to make the unless go away? Is it something the browser might, if the browser is just going to restart it by itself and that's its obligation, then don't give me the event. I don't care. It'll fix itself for a while. Right?
So there's one thing. So there are different ways to look at this. So this might be audio video going over the same transport, and this kicks for the video, and audio is still going, right? Because the circuit breaker did not trigger for it. And there was persistent loss on the video, and there was also some loss on the audio, let's say. And then the circuit breaker triggered. The app could indeed go and look at the stats for the other streams and see if the whatever things that they were seeing before have mitigated or not. So for example, in this case, the audio says, yeah, everything's working all right. And maybe at a sufficient point in the future, the app might just say re-enable a video. I think that's a totally logical thing for it to do and see if the circuit breaker triggers again. It might just be something that the app could do, and then the event's really useful because it gets an event, it knows what was the context in which it triggered. The case where the ice goes away and the circuit breaker triggers, you get two events, right? You get both the ice event and you get the circuit breaker. So you could actually just ignore the circuit breaker at that point because you know the underlying transport's actually gone.
So, I mean, I think from the point of view of this draft, whether it is the browser that makes that decision because it knows something has changed in the network, or whether the browser punts that to the JavaScript app and the JavaScript app then decides when something has changed, I think doesn't matter for this draft. And it clearly matters to WebRTC, but I don't think it affects this draft. As long as something somewhere sort of says, okay, something has changed, therefore we should maybe try restarting.
Jonathan, thanks. I mean, I think that JavaScript APIs are not even in scope of this organization, let alone this working group. That said, I think that the question of what's happening to this microphone.
That microphone is very poorly attached.
I see that. Question of what happens, I think, of whether an ice change counts as reasonably expected, I think might be in scope. Like if you do an ice restart and get a fresh path, that may be a reasonably expected. If you do an ice restart and get the same path, well, maybe it's not. Maybe it's, you know.
But this draft has to be a little vague about that because there are so many things that could count as an indication that something has changed in the network, and I don't think we can possibly list them all. But yeah, I would say if you restart ICE and you're switched to a different candidate, then yeah, clearly you can then infer that yeah, probably something has changed and you should try again.
Peter Thatcher. So even if it's not in this draft, somebody does need to figure out how ICE affects the circuit breaker, because if it's always the fact that an ICE restart causes it to immediately reset the circuit breaker even before you have the new connection, then an application in a WebRTC context could use that to bypass circuit breakers, which is something we probably don't want to have happen, right?
So my guess would be that it would only reset things if it changed to a different interface or something like that.
Right, so we need to like figure that out and write it down.
And if someone wants to suggest text to go in here to clarify that as another example, then sure. Well, no,
I think we've had this discussion before in a different working group, and I think we came to the conclusion that the text almost is here because this circuit breaker applies to a flow. So if you change to a different interface or something like that, or a different, and this is nothing about ICE, right? The ICE is not a connection. It's a different connection. It's a bunch of connections. And if the connection was a different flow, the circuit breaker wouldn't have blown for the other thing. It only blew for the flow that blew, right? And so, I mean, we'll go log a bug right now that the WebRTC guys need an event for when the circuit breakers blow. No one's going to argue about that. And I think this is good.
If you want to give more examples here, please send me the examples and I will add them.
No, this is perfect.
Okay, in that case, we'll leave it. Right. Next slide, please.
So there's one thing that perhaps needs clarification in the document, and that is the fact that there's perhaps not enough guidance to say that if the circuit breaker triggers on an SSRC, do you just reset the SSRC or do you reset all streams that go on that ICE transport?
That is on, I think, the next slide.
Yeah, okay.
Okay. Right, so the final set of comments. From Stephen Farrell, they were pretty straightforward. He wanted some clarification about what it meant to operate within the envelope specified by this memo. So that was easy. A comment from Alyssa was about RTP flows sharing the 5-tuple, and her comment was it used to say you kill the call. It now got clarified to say kill all the flows sharing the 5-tuple. Now, of course, what it actually says is what cease transmission means is either stops the transmission or reduce by a factor of 10. Now, as far as I'm concerned, if you wish to reduce by a factor of 10 by stopping the video and leaving the audio running, for example, that would be a perfectly reasonable way of doing it. So it's a little vague, but you know, if you think there are additional clarifications needed to that text, by all means send them. But it does currently say kill everything on a 5-tuple.
Move to a different 5-tuple.
Right.
Just move to an adjacent 5-tuple. Thompson,
we should be fine because it might be a different NAT binding and then work better.
All of those sorts of things, yeah. So the clarification that you just gave us here is probably quite valuable, I think.
I
Even
think it's already in the draft, but if it's not, yeah, yes, we should
if it's
have
not,
it, yeah.
then yeah.
And if somebody, whoever is taking notes, can please send me a reminder.
So with that rule, then if you did an ICE restart, ended up on a different 5 tuple, but everything else is the same. It's just the ports changed. Then it would retrigger. It would reset the circuit breaker.
I mean, what it says is if you have some reasonable expectation that you're on a different path and would have different congestion conditions, then you can restart. Now, whether you treat...
Do you mean reset the call or reset?
Like you stop and then you switch to a different port, but everything else on the path is the same. Just the port number changed. Now, are you still reset? I mean, do you start sending again, or are you still stopped?
Everything's the same.
Start sending after a little bit rate and wrap up.
Right.
Okay.
Like do whatever.
I mean, we can't give precise guidance for every single case because there's essentially an infinite number of cases. So it tries to give the general guidance, which is if you have some reasonable expectation that the conditions have changed, then you can restart. So, and yes, that runs the risk that people try and hit corner cases and game it. Sure.
So, may I comment? So personally comment from Magnus. So Peter, in this case, if you just change a port, you need to have your bottleneck somewhere where the port affects the path, which means some advanced load. I would central network load balancer or something like that.
Or a carrier grade NAT.
Yeah.
Yeah, I mean, if you're behind a carrier grade NAT, then changing the port may well mean you're on a different path and give you different congestion behavior. Yeah. We love the internet, really. All right. The other point, which is the one which has actually been causing all the fun on the list, was that what the draft said before was, so what we've done is we've changed the discussion of how the circuit breaker should respond to ECN marks. What it said in the previous one was ECN mark packets should be treated as if they were lost when calculating the congestion circuit breaker. And that's changed into a significantly more expanded recommendation. Next slide, please. That is the significantly more expanded recommendation. Great. And clearly you can't read a word of that. Next slide, please. So essentially there are two questions that are coming out of this. Right. And what I'd like to do is present these and then present what I'm proposing to do, and then we'll discuss it, rather than trying to discuss these piecemeal, because we'll just get into a horrible mess. So the questions are, if you're getting persistent excessive congestion signaled by ECN CE marks, should that trigger the circuit breaker? Or should the circuit breaker only be triggered by persistent excessive congestion signaled by packets being thrown away? And what is in the latest version of the draft says, well, if you just get a bunch of ECN CE marks, you may just ignore them and just only treat the circuit breaker if you start getting lots of packet loss. And that text came as a result of a very long discussion in an offline phone call between myself and Varun and Magnus and Miria. And then we put it into the draft and onto the list. And some people said, that's completely wrong. Next slide, please. The other open issue is, if you decide that the circuit breaker should respond to ECN CE marks, how should it respond? Now, if you read what's in RFC 3168, which is the ECN spec, and if you read RFC 6679, which is the ECN for RTP spec, they both say variant on the response to ECN must be essentially the same as the response to packet loss. And that was what was in the draft, the -15 version of the draft. And we got to discuss on that, saying that's not appropriate. The reason for that was partly because of the L4S buff, which happened in the previous slot, which is wanting to do something wild and wacky and completely change the ECN semantics. It's partly because AQM schemes like CODL and Pi have very short queues, and therefore there is some argument that the response to ECN CE mark should be different to the response to loss. And there was one of Michael Wessel's students, his PhD was looking at this for TCP, and he came with a very good reason why TCP should respond differently. But that's based on the dynamics of how TCP manages window-based congestion control. And
perhaps something similar should happen for the RMCAT candidates, but it's not clear what, because the precise analysis he used is very tied to TCP. And so it turns out to be quite unclear what the right thing to do is here. And some people are very, very adamant that doing what RFC 3168 says you must do is not the right thing to do, but there doesn't seem to be agreement of what the right thing is. Next slide, please. So the question is what we put in the draft to move forward. What I'm suggesting is essentially this middle paragraph is the important one here, is that we should put something in that says, at the time of this writing, there is no consensus on how the receipt of ECN feedback will impact the congestion circuit breaker, or indeed whether the congestion circuit breaker ought to take ECN feedback into account. A future version of this memo is expected to provide guidance to implementers. So basically it says we do not know how to deal with this. And I then propose that we publish it with that statement in it and immediately submit a -bis00 and let the argument continue. And given that there was just an initial non-working group forming BOF about L4S, I expect it will take another 4 years to resolve that argument. But I don't think we need to hold this draft up waiting for that.
Go ahead. Jonathan, I suggest saying a future version of this memo is expected to provide guidance and then never publish that memo. That is quite likely, yes.
I think I'm on the almost the same thing, which is roughly to say that the IETF defined ECN to mean one thing. It is now trying to define it to mean something different, but they haven't decided what yet. Given how some things were implemented before the redefinition stage, these bits will be forever useless, and therefore we would suggest you ignore them. I mean, that's the end conclusion we're reaching here.
I think that's the more, I think what I'm trying to say is the more polite version of that. Yes. Now, if there are strong reasons to change what I put in that paragraph, we can of course have that discussion. However, we have had a lengthy offline discussion with the area directors, and they are happy with that text. So if there are not strong reasons, let's not wordsmith this unnecessarily, if we're generally happy with the approach. Next slide. So that's essentially it. What I am hoping we can do is make that change to section 7, submit an update, then let the ISG publish this thing. Once the RFC comes out, I will then submit a BIS draft, which is well, probably reinstates the old version, and then we'll start the discussion about ECN all over again. I'll be talking more about this sort of thing in TSV if you really care about the gory details of ECN and circuit breakers and all that sort of thing. If you just care about RTP and what to do for ECN response, I would suggest you don't go to that discussion. It will just make you raise your blood pressure. And that is it.
Okay. Yeah. One comment from me. I mean, I think for especially the people who care about RTC Web and WebRTC, I don't see going with this, it not specified has any impact because we don't specify the use of ECN for RTP over UDP anyway. So, well.
Yeah, I mean, this doesn't affect what WebRTC is doing.
Yeah.
It was a future-proofing thing.
Yeah.
So you ask if it's agreement.
Yeah. I'm agreeing. I just coming in on the or the detail people might yeah.
Anybody speaks against this, right? We didn't hear anybody speaking against it, so it looks like that's the way to go forward and to finish this work. Any objections or? Okay, so that's what we should put in the meeting notes.
Yeah, room consensus to go with the proposed text.
So I should submit an update with the proposed text.
Yeah.
Okay, I will do that now. Thank you.
That was the last for this one, right? And we start the.
I can vacate it.
Hmm?
I can vacate.
Oh,
Do you want me to have
yeah,
stuff?
if you
Yeah.
could stay with the
Yeah.
conference. So now we're going to. So we'll now go to the payload part of the AVT session. Yeah. So no, we don't have a different blue sheets because we were supposed to have it only as part of the AVT core because we didn't look for a session on payload. a problem with payload. We are not always sure if there will be someone who there'll be some presentation, and mostly because of the that's okay. So the not well, and that's because of the agenda, but because we needed to have some presentation on the flexible FAQ, which is something that we want to progress and finish. And if the time permitting, there's a new RTP payload format for HTTP adaptive streaming. So the document status, there's in the RFC editor queue, there's the payload how-to, which was a misref, and other document, the SMPTE 291 ancillary data. It's after working group last call and need a new revision to address the comment. I asked the author to address the comment. There was an email on the list, I think yesterday, from the author trying to address all the comments that were on the list, and he will need to update the document accordingly. The MELP is ready for working group last call, and we'll do a working group last call. We got a lot of people asking for it to be published, so we'll progress that one. There's a RTP payload format for VC28 high quality profile video. It's adopted as a working group document, and we need reviews on this one. And I hope people will find some time to review the payload documents. The VP9 is there. I don't know what's the current status for that. Maybe.
Jonathan Lennox as an author. I believe, I mean, our opinion is I believe that's, the packet, the payload format proper, the bits in the RTP payload is complete. I'm less certain about the STP offer answer sections, and there's a lot of explanatory text about VP9 that still is missing.
Okay, because it was just going on the list. There were nothing. So that's why I said there's nothing on it currently. Okay, thanks. New work, there's RTP payload format for HTTP adaptive streaming. We'll hope to present it. It's a new RTP payload format for encapsulated the HTTP adaptive streaming data into RTP. I think we will have enough time to address that, hopefully. As for the milestones, okay, so here we have some problems because, I mean, we have a lot of old documents that nobody is really, payloads that are not being progressed, and we'll have to decide what to do with it. Hopefully, maybe we'll try to take them off, because if people are not updating or don't have show interest to progress that, then there's no reason to keep the milestone. We have the ones that we have active is the non-interleave and interleave parity FAQ. That's the one that's a flexible PAC. We just kept the previous milestone, but the document name change. And there's the VP9 and SMPTE 209. The two new milestones about the MLP and the VC2HQ. That's the new milestones. Okay, so this is about the status. Any comments about this working group status, questions? Okay, so we can go to the who's the flexible FAQ? Varun, you're presenting.
Hello again. I'm Varun Singh, presenting on behalf of my co-authors, Mo and Ali and Giri. Next slide, please. So update since 01, where we incorporate feedback from Yokohama. We didn't present in Buenos Aires. So now we have a single FEC packet, which can be decoded as a retransmission request. So we had that covered, and that was part of the design that was incorporated, or we got feedback in Yokohama. Next slide, please. In the period since then, there was a Cisco IPR, which pertains to the protection of multiple source RTP streams. This is regular Cisco terms, I think. If anyone has any feedback on it, please go ahead. Otherwise,
so if people have any concern, they should send to the list, because otherwise we'll just say that it's okay to have this IPR on the document and continue as is without trying to find any other way to go around it.
Jonathan, and I mean, not that we want to be identifying IPR, but as far as I can tell from the bullet point here, it's perfectly easy to use this, you say, in a mode where it doesn't hit the, where you don't protect multiple source RTP streams. And as far as you know, that doesn't.
Yeah.
Okay.
So if we remove that feature.
Or you don't have to use that feature.
Yeah.
Bernardo about Microsoft. In fact, it's not even clear how you would use that feature, right? Because if you'd need like multiple RRID header extensions to like make that clear.
No, no, because there are SSRCs in the packet.
Okay.
The RRID is supposed to be temporary, forever. Next slide. So in Yokohama, we decided that we would do retransmissions, which was basically say a bunch of flags set to 1, and SSRC count equal to 1, and then you would have SN base. So the whole point of this slide was to show that you have a bunch of extra, you have reserved bits there, and you have SSRC count equal to 1. So we were thinking if we could just, in the next slide, remove that grayed out thing and just make retransmissions as like without that bit of information. So we save about 32 bits. So it's 1, 2, 3. So instead of 8 words, we're down to 7. And if this is an optimization that people think is worthwhile, we'll incorporate it and move forward. So go back one slide. The point is to remove the gray line, 32-bit word, which just says there's only one sequence number, or there's only one SSRC in this packet. Go back one.
Jonathan, is that just for the RTX, or is that a general? There's only one SSRC in this packet.
That's only for RTX.
Can you go back to the other slide? Is there a reason that has to be only for RTX?
Yeah, because the red one, that's the.
I should clarify that one. The first red one bit is retransmission or not. So the first bit is fixed or flexible. So
Okay.
like you can have fixed or flexible scalability structure,
Mm-hmm.
and then the next bit is retransmission or not. If it's retransmission, then you don't need all the rest of the stuff. You don't need you're only protecting one packet with no code. Effectively. So you don't need the mask or the N and M counts.
Can I see the other slide, the new format?
Well,
sorry.
That's just removing the 32-bit word from it.
I mean, how am I distinguishing which one is which here?
Which one's which? You mean FAC packet versus retransmission?
Yeah.
Yeah, that's the second bit, which
But
is.
they're both ones, aren't they?
Yeah.
What?
No,
Oh,
it's
it's old.
old and
Oh,
new.
I see. Okay.
It's just still the retransmission.
And actually, Mos and I, sorry, I'm just thinking on the fly. I don't think we probably didn't put enough thought into this because I think you could eliminate length recovery too, and then move the reserved, and then you're gaining back another whole word. Because length recovery, you don't need the length, right? It's just one single packet. So the length of the packet that you're getting is the length.
Right.
So you don't need the length recovery anymore. It's recovered by the packet itself. So then you could remove the reserved and we could save another word. So the whole point of this was when we presented the retransmission proposal, people liked it, but then they didn't like that it took that the effect header was big. And I think it was Justin specifically, unfortunately he's not here now. He said, if you're using this for audio, it really blows out the audio bandwidths to have this big of effect header for a retransmission packet. We'd rather just use old RFC 4588 RETX. It's more complexity, but it's more efficient. So the goal here is to make it as efficient as other retransmission schemes, but not having the complexity of having to negotiate a bunch of different repair mechanisms.
Yeah, I think I was going to say that the recovery procedures would become difficult, but this retransmission set probably doesn't apply because the decoding or the encoding of the FAC packet requires some processing, and especially depending on what kind of code you use, you need to know how to recover. And if you keep moving the fields around, it makes it really tedious for an implementer then he has to like put extra thought into like processing the packet when it comes in, because you cannot reuse the same code base. At which point you could actually just say that let's do a different payload format and stop juggling fields around. And I think if we start moving fields which were in the same place to another place, that's
I think the right question for the work group is, do we think that having a consolidated repair mechanism is useful? And if so, is it useful to minimize the signaling complexity and the implementation complexity of all that, but at the expense of you have a parsing complexity here, because based on the first 2 bits of the packet format, you need to know which way to interpret the packet. So that's really the crux of the issue. And does the work group think that doing that extra work to have the switchable formats with those first 2 bits and saving the signaling complexity and the rest of the implementation complexity is worth it? Or should we have 2 totally different schemes for effect versus retransmission?
So this is a different question. The first question is that about this change. I mean, about this change. And I was suggesting we have another change also.
Yeah,
you're right.
I think this is non-controversial. Now the point is to remove length recovery.
Yeah, I understand, but just to be clear that that's on top of this 2 separate changes.
Bernard about Microsoft. I wanted to second the idea that if you're, I do think it is desirable to have it do retransmission as well. But as Justin said, if you're going to do that, you really have to kind of really kill RTX, right? You really have to do it. And that means you have to optimize the thing so it really makes any desire to do RTX go away. And I think you might even be able to save even more bits if you really were to get down to it.
I think if you're going to save more bits, we're down to that point where we probably should do a different format. I
don't personally think it's that bad, because you just look at this, you get the bit and you kind of know what the rest of it looks like, as long as it's not totally weird and you have to do a lot of other things to figure it out.
Yeah, you could even throw the TS recovery.
Then it's okay.
Peter Thatcher. I think reading a bit and then having an if statement that says, if this bit parse this way, else parse this way, is pretty simple. I mean, I'm not too worried about that. And if you're trading off that versus having the potential to kill off RTX and all its complexity, I think that's completely worth it. So if most question is this worth it, then I guess say a big yes.
I guess an easier way to do this draft is then actually split out the sections into 2, because I think currently that if statement really is if you're going to nuke all these things like TS recovery and put the SN base there and just put the SSRC, we're basically saying that parse it exactly differently, right? It's just the first 2 bits that decide what to do, and that's fine.
That sounds fine.
Okay.
Yeah, bravo, Microsoft. RTX really is a huge pain the way it exists. And having something that would actually work well, I think it would be a huge contribution, because it really is very, very painful.
So if you're going down this path, I'm going to ask this question again. Is there something else that's missing? Because the worst thing that we would want is that I'm standing here in Korea and we're saying oh, you know what? We want to add 8 bits somewhere. So if we nuke all these things and we remove the TS recovery, move the SN base there, then we're down to even fewer bits. And
I mean, for us, I'd be very moving RTX. Yeah, sure, it'd be great. If we were redoing the world over again, we could do a better design. But the loss of backwards compatibility with the huge amount of equipment that does RTX is just going to make. I'm not going to do this, right? It's just not. It's not enough better than RTX to be worth replacing RTX. So.
Yeah, but if you just look at all the pain that RTX brings, all the payload type allocations and all that, it really, and the parsing of the thing and tracking what goes with what, especially when you're dealing with fairly complex scenarios. And that's not to say everybody's going to do this, everybody's going to try to do it, but just at the end of the day, the amount of code and stuff is going to be really, really painful.
So from a perspective of, applications that don't have to work with legacy equipment and they have kind of their only work with their own app, if you went to them and said, you can choose to use the old RTX with all this complexity or the new thing and it just works, everybody's going to pick the new thing, right? And they don't have to worry about so for them, it's very valuable to have the new thing, even if it's not valuable in all cases.
Jonathan Lennox. I mean, I would push back a little bit on removing the TS recovery field because I feel like one of the pain points with RTX has always been that things like jitter calculations make absolutely no sense on that stream. So I think having the TS field, the actual RTPT timestamp be something vaguely corresponding to transmission time, and so that jitter calculations on the stream make sense is a useful thing. I don't think we want to.
Okay.
Yeah.
But you.
Proposing the length recovery.
Again, somebody length recovery going, I understand, but somebody also mentioned removing TS, and I think you can't remove TS.
Yeah, but if we probably have to overlook, like I think the TS recovery currently says something else. Probably need to redefine it.
Yeah, Mo, again, I think the whole point of having TS recovery period in these packet formats is exactly what Jonathan said. People thought it was untenable to have, TS jumping around, not monotonically with the sequence numbers. So it was, I think that's something we really can't touch.
Okay.
Okay, so it looks like, I mean, you have to send it to the list just to verify what's the change, because there's a different, because the first change nobody really cared about. I mean, nobody said against it, but they were suggesting more changes, like the lens recovery in the reserve bit to reduce. So just send it to the list, and
I will do that. Next slide. So in Yokohama, when we discussed this, we said, how do we indicate the FAC type or what code you're using in the code blocks? So we said we would indicate that in SDP encode equal to XR. So the question became, should we have a separate media type registration for this? Should it be like flex FAC XR, or should it be like code equal to XR? So should this be application / flex FAC? And then you have like a code equal to XR, code equal to Reed Solomon, or do we want to go down the path of saying application / flex FAC RS? This, I don't have a very strong opinion about this, but people may look at this differently, and I think we need to, if you're going to have different types of FAC mechanisms, we probably need a way to, since it's already flexible and claims to be flexible, we will need to be like us allowing for that flexibility here.
Okay. Jonathan Lennox, I mean, I'm moderately inclined towards a separate media type registration because it makes the offer answer codec matching easier. You don't have to add the special code thing in your code to recognize the code equals to figure out which codecs in the offer match the answer. But other than that, it's pretty minor. Yeah.
I guess the main thing is we should pick one now. So.
Yeah. I mean, I think,
So if there's more opinions,
Yeah, I mean, my inclination is towards media type registration, but I'm not gonna, if somebody gives a good reason to do the other way, I'm not gonna fight too hard.
Anyone care more deeply about this?
Bernardo, but a second. The thing I do care deeply is not adding Reed Solomon and Raptor to this draft.
Yeah, that's the second. That's the second question.
Please don't.
So let's. So that's the second part of the document, which is like, what do we do with those? Like those come. They should not be expressly not part of this document, and if so, they'll come as separate.
I think
documents.
that was also discussed in Yokohama. I think that was also what was said in Yokohama, that we should not have those in the document.
Actually, I don't remember that. I do remember having the discussion. I thought we said they could be, and that's why
Okay,
I'm not sure.
we can check also this, but that's not the problem. So about the SDP, the media registration, I mean, that's the most, that's something we need to figure out.
Yeah. So Martin Thompson, I'm here to encourage you. If you want to do Reed Solomon or Raptor or any of these other things, do them as an entirely separate thing.
Mm-hmm.
Take all the lessons you learn here and apply the same sort of excellent design choices that people are applauding, but have a new media type registration and have the whole works, because otherwise you're going to just invent another layer of negotiation, and extra layers of negotiation just cause failures.
Okay. So
the second part, so we do media type registrations and no Reed Solomon Raptor in this draft.
So to summarize what Varun said, I mean, on the first one, separate media type registration for the nodes, and the second one, the Solomon Raptors new draft. That's
or not.
it's new draft. It means yes or not. I mean, that's separate. I mean, new draft depends who writes it, right?
Next slide. I think I'm running out of slides. Oh yeah, and next steps, we need to finish up the document. Since we've been changing the packet format every meeting, We've not changed the recovery procedures and like the encoding procedures. And I think now we have a stable, at least the fact part's not changed this time. So we can go ahead and do that and incorporate the changes from this thing. I hope to have this out fairly soon because and send to the mailing list the retransmission thing, and then we should be able to move forward on this. Thank you.
Okay, thank you. Jonathan.
Thanks. One question which I probably would know the answer to if I'd read the draft recently. Do we have any discussion on this of whether you're doing FEC before or after SRTP?
Oh.
So you're assuming you're doing it after? We don't support FEC over the encrypted payloads with this?
I think we had this discussion really early on when we started to write this document, and I think that time the discussion was that we do it on the unencrypted media.
Okay.
So
which, I mean, we'll have to presumably might have to revisit for PERC, but that would possibly be in the context of PERC.
So it's after. Currently, it's after.
Yeah. Yeah. So you,
unencrypted. Maybe.
Yeah, it's unencrypted.
Okay.
It's flexibility. So if people think, I guess
I don't know. I mean, I think it's particularly hard once you get to like things like GCM where I don't even because the auth tags are different. I give FEC of encrypted payloads with ICM is I can sort of get my head around. Flex of encrypted packets with GCM makes my head hurt. So I don't know.
I think it was discussed before also. We had some conclusion about it. We have to go back to the notes.
I think
this issue was discussed.
Yeah, and it was before it was encrypted. So
yeah. Okay. Thanks. So now we have the last presentation, Rachel.
Okay. Hi, everyone. I'm Rachel Huang. I'm going to present it on behalf of my other co-authors. This work called has over RTP. Yes, please. Currently, OTT live content is becoming popular, and the OTT content is flooding the operators' network, especially when people watching 4K and 8K video. And some operators may only has multicast video transport network, and they lack of content, and they may want get the content from the OTT content providers. So people are starting to thinking, why don't we use transport the HTTP streaming data into multicast? The benefit is that OTT live content can be well supported, and the network pressure can be greatly reduced. And compared to the CDN solution, multicast doesn't need to reserve the bandwidth and the resources at the peak time, so it can get the maximum the revenue. That's why multicast ABR is raised. So currently, multicast ABR is specified in Cable Labs. Multicast ABR uses different multicast groups to transport different bit rates of the same content, so that the multicast receiver can achieve adaptive streaming by dynamically join different multicast group. Currently, the multicast ABR in Cable Labs is deployed in the home gateway, so that it can have the ability to transport to convert the multicast into unicast, so that the devices in the home network can applications of the home devices don't need to do any changes, just use traditional HTTP streaming data. So so next, please. Multicast ABR in Cable Labs uses NOM to deliver the hash data in multicast. But we think maybe RTP is more suitable in this case for compared to NOM, because RTP has following advantages. For example, RTP has several existing mechanisms like fast channel change and retransmission and maybe effect. And also some telecom operators only have IPTV multicast platform based on RTP, which may not easily to support normal protocol because it is a very complex protocol. And also RTP is native to support the multimedia data and has data is essentially the multimedia data. And also RTP is already supported in some end user devices like set-top boxes. So that the multicast can go directly, easily directly to the end users. For example, shown in the following figure. Next, please. So when we dig it further, we find that there are several things that we should be considered when we want to use the RTP to transport HAS. First of all, we need RTP payload for HAS. Secondly, we need to consider how to handle the manifest files. And considering the HAS segment is usually very large, how to efficiently transporting RTP. So we may need some work towards fragmentation. And the multicast congestion control is totally different from the unicast one. So maybe we need some considerations in this area. Next, please. So this slide, this page shows the RTP payload format for HAS. I'm not going to detail it. It's just a very initial idea. And I need a lot of work, further work and discussions to make it more suitable for HAS. Next, please. These are some other considerations for other three work. As for the manifest files, there are two ways to transport it: out of band, in band, and we may not. And the manifest files may not be needed at all when considering the multicast directly to the end user. And we also need to consider how to signaling the multicast group information. Maybe the multicast files need to be extended, or maybe SGP protocols. As for the fragmentation considerations, it is required to split the HAS segment into RTP packets that can be decodable. The best option is that we may wish the manifest files could be modified so that allows the OTT content provider to indicate the fragmentation points in the manifest file, so that the OTT servers, no, not OTT servers, sorry, multicast servers can easily figure out where the decodable fragment, decodable independent fragmentations, the location can be extracted. So this option may need some work in unpack, considering the congestion control, since multicast clients dynamically join the multicast group based on current network conditions, and multiple multicast groups may share the same bottleneck. So maybe a new congestion control mechanism is required in this case to coordinate multicast clients with the same problem. And some maybe strategies should be considered so that the all of the multicast clients have the same problem could get the best quality they can have. So I believe this is the last slide. So basically, this is the whole work of it, and I would like to see how people think of it and comments and suggestions.
Varun Singh, I had a question, and this is mainly like I can't wrap my head around the deployment scenario for this because it seems to me that this needs to go into an IPTV kind of network where the downs, or at least I hope my IPTV, or I think my IPTV is in a managed network, or the bitrate that the IPTV gets is totally segregated from the other services that I might be getting on the thing. So the congestion control bit kind of is, I'm not thought through it enough to know why there would be a problem there, because perhaps the downlink or my set-top box already knows what my IPTV should get and should just connect over on the appropriate multicast group. The other thing that I'm kind of not understanding is, like, could you go back to the last slide or last but one? The manifest files and the fragmentation. So the thing with the fragmentation is it's not currently there. So the only thing I can think of is like using smaller chunk sizes here, and for the large chunk sizes, I'm not sure. Without a fragmentation point already being provided in the MPEG manifest, there's not much we can do. And the first one, the how to transmit the manifest files, I'm hoping that the IPTV guys know how to send the information to the client, and that decision should be made by the existing technologies in that space.
So, do you want me to answer that, Rachel? You want me to answer?
You can.
Okay. So for the manifest file, it's more like how to provide the information about those multicast groups, that each of them have a different resolution, which is not currently available. So you want to provide this to the multicast client. You need to provide to the multicast client somehow. It's not the original manifest file, but only this part of information that needs to be included somehow.
So as far as I understand correctly, the IPTV clients do not really understand any of the manifest files anyway. So they do understand somehow, like how the EPG arrives on my TV. I actually don't know anything about this. So I'm assuming this is like SAP or some of those old things that existed before even I knew how to code. But I'm really wondering, like, just by adding, I understand you want to add multicast groups into the manifest file, but I'm still trying to wrap my head around the fact that how does the thing that cannot be changed to do HTTP understands how to read the manifest file.
So Magnus Westland, I think there's a clear mismatch here between appropriate protocol use, etc. I think the ones that use norm for this type of the really right choice. Use a reliable multicast transport protocol to transport something which is files and have all this in, and it's matching the HTTP scheme that you actually have, so you can deliver the manifest over the multicast, you can deliver each segments over the multicasts, and you can put them on the different side. I think what's really missing in that type of scheme to actually make it easier to lift is something which has already been proposed in IETF. I think, for example, by Dave Singer and Apple, is actually URI formats for how to invoke multicast delivery from, for example, in a browser or similar environments. So, and he looked at, I think it was Flute or if it was Fcast, but it's the same principle that you need, say, maybe something that you can invoke, saying, okay, start with HTTP, being able to say, okay, go fetch this on this multicast group. Here's the parameterization to be able to use Fcast, Flute, or Norm to just start delivering it. That, I think, is a much more appropriate model than trying to solve or redo a lot of these things, which in RTP here, it's not the appropriate. It's use.
Bernard about Microsoft. I wanted to second what Magnus just said. I think this is reinventing one of 3 possible wheels. And I don't think we need to reinvent any of them. So I think we should just use existing things.
Mozanati. I was curious, is it prohibitive to take the chunk and demux it and just send it over multicast RTP? Demuxed? Why would that not be a simple solution? So instead of streaming a multiplexed container as a new format over RTP, clearly the audio and video elementary streams would already have container form bindings for RTP. Could you just demux the container, and then stream over multicast RTP the individual elementary streams?
It would be a size issue.
Size?
Because the chunk of the is bigger. I mean, okay.
If I may, I think I might respond to it. I think the one reason why it might not work is that what's produced for the internet streaming video in encoding a buffer model doesn't fit the IPTV buffer model. That might be the main problem here, because there are actually implications in IPTV for buffering models, etc., and encoding models.
But I'm not suggesting transcoding the media. I'm just saying remux the media. Just demux it. Don't even remux it.
And that I was saying is that the media within the file, the segments, might not fit the buffer requirements that the IPTV system has put to be able to be decoded by the set-top box.
I mean, conceptually, this is the exact same data of the exact same size. Only the difference would be TCP and HTTP headers over it versus RTP UDP headers over it, and stripping container metadata that you would maybe have to figure out a different way to convey.
Colin Perkins. So I perhaps misunderstood the draft, but I thought what was being proposed was something much simpler. So I would agree with Magnus, but I don't think that's what's being proposed here. I thought what this draft was suggesting was take the content that's in the dash chunks, fragment it appropriately and put it into RTP packets and just send them, and then the video they get played. And I don't see. I mean, there's a question about do we really need the manifest files? And I think the answer is just no. You just you have an SDP file that says, well, you know, this quality setting is on this multicast group, and then you just fragment the multiplexed dash chunks, and if you do that in a slightly smart way, then the receivers can just play them out. And okay, they may need to have slightly bigger buffers than a typical receiver, but you're going to have to add in support for a new payload format anyway. So, I mean, that doesn't, to me, seem like a crazy thing to do. Just a way of gatewaying the multiplex dash stuff onto a multicast group.
Varun Singh. So I didn't want to come off as a person who doesn't like any of these ideas. The main thing here is, I think the work that could be done here is the second bit of fragmenting the chunk sizes into RTP packets. I think that's the relevant bit, and all the other things are totally out of scope. And actually understanding on how to how to fragment a chunk stream is perhaps, if there's already guidance on how to do it, I would just say we follow that guidance and just say, these are the boundaries on which we could do it.
So we are a bit over time because it's 6:20 and we need to finish. So just
Bernard, I mean, maybe I'm just confused, but in the existing payload formats, there's often a way to do that fragmentation that's already been done, right? I mean, or fragmentation units.
Sure. So I mean, if in the existing payload formats, yeah, obviously that's already done. But then the box which was taking the dash files, the dash media files, and putting them onto RTP would need to understand those files well enough to rip them apart and re-encode them in the new formats. I thought this was suggesting, well, have essentially a hint track that just says, just do a blind split at these places, stick an RTP header on the front and send it. And if it's smart about where, you know, if the person who generates the hint track is smart, then that would seem reasonable.
Okay, so we'll continue this discussion on this. Thank you. And this concludes the full AVT session that we had today. And we'll see you all next meeting in Seoul. Blue sheets? Yeah. Okay, thank you. And now you can go to the social, those who go there.
I guess the guy who will manage the fire screen that's actually not sure. Oh, yeah.